Hi, my name is Natalie Villafranca, and I'm going to be talking about the ecological implications of physics in the ocean. To start out, here is an outline of the physics concepts that I'm going to be talking about during this presentation. So first I'll discuss speed, velocity, and acceleration. Then I'll talk about momentum, pressure, and drag. So here's an image that illustrates the different ways that marine vertebrates have evolved to swim. Vertebrates that have undulatory swimming, which is on the left, are actually more related to mammals, while fish are more related to reptiles. So the ones more on the right, the oscillatory, are closer related to reptiles. An example of undulatory fish, specifically anguilliform, would be an eel. Eels have very long, slender bodies, so they kind of like that, just like it says on the very left picture. And then an example of a subcarangiform is a trout. Trouts have really pretty stiff bodies, which means that most of the work is being done by their tails. Next is a carangiform fish, who are also stiff but pretty fast. Their tails are what do most of the work. Thuniforms are the fastest kind of fish. Their tails are crescent-shaped, which is what gives most of the movement. An example of these would be barracudas and tunas. Lastly is the ostraciform group. They use tiny little tails to move around, so they don't move very much. An example of this would be boxfish, also known as pufferfish. They're really cute. So this slide has pictures of a few different fish and their max speeds. As said earlier, tunas are some of the fastest fish and can swim up to 23 meters per second. Interestingly, Monterey eels and whale sharks swim at the same speed, despite the fact that their weights and body structures differ so vastly. The manta ray also has a unique way of swimming. It's actually called mobuliform. The manta ray can swim 7 meters per second, up to 7 meters per second. So the main concepts I want to focus on are speed and acceleration. Speed is the rate of change in the position of an object, also distance over time, so like meters per second. Velocity is displacement over time, which is how fast something is moving and in what direction. Acceleration is a change in velocity over time, which ends up being the rate at which the velocity changes. In the slide before this, I put the different speeds of different marine vertebrates. These different speeds are really important to each animal, as it is what allows them to protect themselves from predators, but also to prey on other animals. Each of these animals are pretty prevalent species, which means that evolutionarily their speed and acceleration, as well as other factors like the ability to sting in eels and manta rays, has been beneficial to them and the continuation of their species. As shown in the first slide, all of these animals have very unique ways of moving, and each one has evolved with that type of movement for a reason. The next term I want to talk about is momentum. Momentum is the quantity of motion of a moving body, measured as a product of its mass and velocity. In this slide, I have two of the fastest fish. In fact, the sailfish is the fastest fish. Barracudas are also known to be pretty fast. The barracuda weighs 6 kilograms, but can go 16 meters per second, while the sailfish weighs 54 kilograms and can go 31 meters per second, which makes their momentum, momentum is m times v, so 96 for barracudas, 96 kilograms meters per second for barracudas, and then 1,674 kilograms meters per second for the sailfish. Because momentum is a vector quantity, it would also have to be said which direction these fish were going in. Another really important factor for the ocean is pressure, specifically water pressure. This is measured as the amount of force exerted on something. As you go down deeper into the ocean, the water pressure increases. However, this means that the animals that exist in shallower water are not the same as animals that exist in deeper waters. This is a picture of what is commonly called a blobfish. The natural habitat of these fish is 3,000 feet below sea level. Humans can't even go that deep scuba diving. The only way for these to be seen is through an ROV sent down. The left photo is what the fish is supposed to look like at 3,000 feet, while the right fish is what causes it to be a blobfish when fishers rapidly pull it up and it's not in its environment anymore. Um, it's a similar phenomena to this would be like if a scuba diver goes scuba diving and gets the bends because they change pressures from really deep to really shallow too quickly. So you get the bends, your lungs fill with nitrogen bubbles. You have to go into recompression chamber. Or if a fish goes down deep too fast, it causes their swim bladder to expand and then it explodes to the rest of their organs. So pressure is another really important factor for the ecology of different animals and determines which animals are present in which environments. Lastly, drag is also an important factor in ecology. Drag is the friction that is created when the force of an object that resists its motion in a fluid, which in this case, it's salt water. Different animals have different levels of drag. Those with more drag are slower. The seahorse is an example of a high drag animal. Their anatomy is not very efficient, but it is pretty. It is not long, slender, or straight, but curvy and small, and it has all these little like figures popping off of it, which gives it a higher resistance to water. So while the seahorse can only go 5 feet per hour, which is really cute, the swordfish is really drag efficient and can travel 27 meters per second or 60 miles per hour. What makes the swordfish so efficient is its body structure, how it's long and slender and doesn't have too much going on. Its crescent tail is also very helpful when it comes to speed, which we talked about earlier in like the very first slide. So what does all of this mean in terms of ecology? How does the physics of animals affect how they interact with each other? Well, swimming performance affects the species' ability to be efficient predators or prey. The optimal foraging theory says that animals will maximize their energy gains at the lowest cost to maximize their fitness. So animals want to exert the least physical energy to capture a specific prey. Animals who are more fit will likely be top predators. So animals like sharks are top predators because they're so fit, well, also because of their teeth, but they're fast and are really good at capturing prey. While maybe a seahorse that's really slow might be a bottom level prey. So it is important to know how fast a specific species can know in order to better understand its relationship with the environment. So in conclusion, everything is physics. Thanks.